Roman concrete.
Fully hydraulic.
Structural
Solid connections.
It's the
Structural
engineering podcast.
No real introduction here. This is part 2 of our conversation with Carl, the mechanical engineer.
So a couple days ago, we posted on Instagram. We did a little story on there and asked people questions on what would they like to ask you.
Yes.
What questions do they have? The first and also the best one that I want to bring up is this. And I'm just going to read it exactly how it came because you can't.
You got to give the user credit. Call them out.
Albany EM. They said, do you first look at my shear walls in order to send ductwork through them, or am I just that lucky? So I reposted that answer on Instagram, and I got so many messages that was like, there is no truer statement in my career than mechanical engineering is putting massive ducts through only my shear walls. No other wall in the building, just my shear walls, Carl. So let me ask you, where in school or where in your initial training did they teach you what a shear wall was? And when did they tell you to only put penetrations through those walls?
I go through everything. I'm everywhere. As I said,
So you go, let me take a stab at this first here. You tell me where my theories are incorrect. I foresee all mechanical engineers, the first thing they do when they get the structural drawings is find the shear walls. Once they find the shear walls, they start putting the biggest holes they can through them.
I think the problem is we shade the shear walls and it just grabs attention. They're like, oh, there's a wall. Let's put a hole there. That one's darker.
Yes, that's a great point.
It highlights itself and just like a magnet, like flies to a bug light. We just got to come and just plow right through it.
So to get back on here.
So something I've learned, and you guys can correct me, and that I think your listeners could maybe educate their mechanical engineers on is my experience with them is that vertical alignment had an effect on you. Like if I was asked to, instead of having lots of penetrations, put them all on top of each other, and especially on top of a doorway, because once you'd already cut a hole somewhere for a doorway, above that didn't have the same effect as if I was trying to be next to a doorway in these walls.
Yeah, and the hard thing is that's so dependent on the structure type, right? If it's stick frame versus concrete versus steel, I mean, there's so many different things going on. Really, the hard thing here is we're really getting down to is coordination and more conversations.
I think my quote that I've pulled from Max at the start of this episode was, "I don't really interact with mechanical." Those were, I think,
you wrote that down.
top. How you introduced this episode.
Okay, so really the coordination. I think the Instagram question was more of a funny point. That
it was awesome. Whoever
Albany is awesome, and there's just no way around it. That's what we're getting to. We have to work together to have a good structure. Max, you and I have to work with the architect, right? We have to fit our stuff within their parameters. Well, we also have to work with the mechanical engineer. Like we're all agreeing with structurally, we don't have to work with electrical, civil, an okay amount, but not that much
if
either.
You don't know each other by first name basis. There's your first clue. If I ask you who your mechanical engineer is and all you know is the company's name, there we go.
Let's change routes a little bit. Earlier you brought up the RTU.
So I have a topic that I'd like to discuss about RTUs.
Perfect. But before you do that, Carl, let's go over some of the something that confused me for a very long time is you guys have so many acronyms for all your different types of units.
Okay.
Could you go over just a couple basic ones? RTU. There's a whole bunch that are on your drawings that you guys use consistently. VAV, you already described what that is, but what are some other common ones that you use, and what are their significance? As a structural engineer, I want to know, to me, condensing units are typically smaller than an RTU. And that's not always true, though. but it allows me to start thinking of significance. RTUs, I've done buildings where RTUs were 30,000 pounds, and you're like, oh my gosh. And then, I have buildings where in a condensing unit's 150 pounds, and I'm like, not very worried, right? So if you wouldn't mind just giving us some of those kind of the 101s of some of those items that you guys are putting on the roof, let's say.
Okay.
Exclusive hot new mix.
RTU, rooftop unit, AHU, which is an air handling unit. VAV, variable airflow, PU, or condenser unit, FCU, fan coil unit, energy recovery ventilator, MAU.
That's awesome.
A useful tool is their cover sheet should have a list of these abbreviations. Also, any decent mechanical engineer will have scheduled a weight. The easy one is, of course, RTU, rooftop unit. Basically, it's a big box that handles our air. It is a outside roof-mounted AHU, which is an air handling unit. If it's inside the building, usually we call it an AHU. VAV systems are the most common. What that is we are modulating the airflow through the system. So it's a variable airflow. It's a way we've found to be more efficient. Old systems used to be constant volume and modulate the temperature of the air that a space received. Another common one was CU, or condenser units. Those are how the refrigerant system is producing the cooling. Those will either be incorporated into your air handler or can be set next to it. Usually everyone who has air conditioning has one sitting outside of their house. FCU, fan coil units, which is just a VAV with a fan in it.
There's one I've dealt with recently that was started with an E.
ERV.
An ERV, exactly. It was inside the building.
Is an energy recovery ventilator. These are units that are usually specialized to just produce outside air. And the goal of that piece of equipment is to recover the energy of the exhaust air. So we put a heat exchanger, and so as we exhaust air, we heat up the outside air and try and get some energy savings there. And the other one might be an MAU, which is a makeup air unit. It's just another RTU, except that a makeup air unit is usually 100% outside air, while an RTU or an AHU usually tends to be recycle the air in a space.
So that's awesome. Those are things I had no clue about when I started.
And a lot of them will, like RTU, AHU, ERV, MAU, they're all a big box for you guys.
What
the difference of the designation is to help mechanical contractors designate the goal and the operation of that piece of equipment. To you guys that are all a big box that we're going to put a fan in and some sort of heating or cooling or heat exchanging equipment.
To the structural engineer, are at a high level, are one of those heavier than the others? Is there a hierarchy of weight? Because really, I couldn't care less what it's doing as long as I understand the weight of the element. And usually, I don't know about you, Max, but usually I go off of what it looks like in plan. If it's huge, it's probably pretty heavy. If it's tiny, it's probably pretty light. And you can't put you can only put so much weight in there.
You're pretty on the point there. Yeah, it's such a wide span, and there's so much different. So a good example is I just had a job, and we were taking an old unit off of a building and replacing it. The unit had a bunch of problems being pre-digital era, so they couldn't even find the old product information. Like someone had scanned an old catalog from before I was even born about this unit, and we're trying to replace it. I'm trying to get new units for the spot, and energy code now requires double-walled unit, doubles the weight. And everything I tried to put on the spot, the structural came back and was like, holy shit, you're twice the existing unit. Like, why is your unit twice as and the unit I wanted to put was 4 times as heavy. They were like, you can't do that.
Welcome
and I had
to our world.
And find a unit that wasn't as effective, that was only double the weight instead of 4 times the weight.
Let me give you a little piece of advice from every structural engineer ever. Find the lightest unit you can and put it on our roof or in our shed.
And that was the issue. This was an existing structure that the structure was like, I can only handle so much. You got to work with me. And so I had to make sacrifices for efficiency and the equipment and the comfort and select a less optimal unit. But we had that discussion and talked about what my weight was going to be.
Do you
Mostly
feel
after I came to it, but they yelled at me.
Do you feel that those are those from the structural engineer when he's telling you that? What's your feeling when you hear that? Like, we can't do that. You're like, oh, come on, or do you
like try harder?
Like try harder. Yeah. Is it like oh, come on, you can do this, or is it like, okay, I understand? Because I feel like if it's a weird game you're playing. You're like, it's gonna weigh 10,000 pounds, and the structural engineer comes back and just says no. Like, there's got to be some part of you that's like, come on, like you've got to be able to make that work.
Right.
What is that interaction like to you when we come back to you and go, hey, I'm sorry, you got to find something lighter.
Right. And a lot of it came down to the conversation we had. So the structural engineer came and said, your unit is 4 times the weight of what the existing was. I don't think I can hold this up. Do you have other options? It was a different conversation than just like, no, it's too heavy. And then that's the end of the conversation. There was a description of what was going on. I explored my options and I came back and I said, okay, the lightest I can do is double. I am running this thing. They've changed the energy code. Units are now built differently. I can't go lighter than this. Can you make this work? And they had to then figure it out. But it was all about that dialogue instead of
Exactly. Back to the whole communication. I'm going to send this home all day, Max, because I think that is the biggest challenge. You can train anyone to be able to be a good engineer and run the best calcs ever, but the communication and the relationship goes forever. It goes so far on a project. The whole project team could win or lose based off of the comfortability, if that's even a word, I don't even know, but of how the team works together, right? We're all going into this as a team. The more we can work together, the better we can communicate. Rather than the engineer's got understanding, and now Carl understands too. You can't just quadruple the weight and have no changes to structure. It becomes very challenging to structure. And so being able to have those conversations of, hey, can this become any lighter? That would make everyone's life a little easier.
I've got maybe a practical question. We'll see.
Okay. And then I have a kind of an industry thing that I wanted to share.
Oh, excellent. So I'm wondering, where in cases where there are conflict between structure and HVAC, what are the smart questions that I can ask that are like alternatives? If I've got a hole way on the edge of a beam, that's extra hard for us, right? Like, we like it in the middle. How hard is it, let's say, to move a beam or like reduct around so you're in the middle, or something in that realm, or like make it a box instead of a circle? What do you think?
Real quick, the best route to go to tell your mechanical engineers the middle third of the beam and the middle third of the depth.
Okay. So it's hard to answer that universally because there's so much things that can be going on in the building. And it's all about having that discussion about like, okay, so here's what I'm trying to accomplish with where I have my penetration. And you can talk about like, okay, well, here's where we can try and make this work. How can, what can you give and take to get there? A lot of the conflicts tend to be where we have our biggest mains or where you have the biggest structure.
Yeah.
Either you've closed off the ceiling space and I have to go through it, or I have the biggest trunks of ductwork, or you can
but how much wiggle room do you have? Let's say I
have a fair amount.
Okay.
The mechanical engineer has a good mechanical engineer can come up with options and design around that.
Yeah.
An example that me and Zach worked out is he had a big piece of ductwork that wanted to go through one of his columns, and
it wanted to.
was like, what do we do? And I was like, honestly, just put it right. Okay. Every mechanical engineer is going to forever hate me for this, but the louver opening on the side of the building needed to be right where a column was. And I said, we can make the column or the louver extra big and just have your beam or your column right in the middle of our louver. And when our air will just go around it, but we have to know and talk about it and make it big. And then I have to box around your column and make this happen. And it could only happen with a good amount of coordination and talking about my solutions and options with you. You can't just expect some mechanical guy or don't ever expect your beam to be allowed to go through our ductwork.
Yeah, and don't worry, no mechanical engineers listening to this show.
Okay, hold on. Then I've got a more specific, because I don't know if this is a dumb question. If you said, hey, Max, can this beam be 2 inches shorter? Yeah, almost always, yes, right? It's going to be uneconomical, super heavy, but we can make a beam 2 inches shorter. If I said, hey, Carl, can this duct be 2 inches smaller? Would you be like, that's not even, no, that's not a thing? Or would you say, oh, well, let me rework, see if that's even a possibility?
For the most part, like 2 inches is very accommodable. The thing to look at is, as we discussed before, the aspect ratio of height to width. So like I can't go down 2 inches from like an 8x40 to a 6x40. Like that's going to have to, that aspect ratio is super off then. You know, if I'm a 12x12 ductwork, I can easily go down 2 inches and be a 10 by 14 or 16. Mm-hmm. The thing is that in ductwork, for every vertical sacrifice we make, you have to make a growing exponential width change because we lose efficiency. So we make it 2 inches shorter, but we might have to go 6 inches wider. And so at some point we end up at like, okay, this doesn't work anymore. But for the most part, we can make accommodations. And usually we end up coming to you after we've tried to make all of those accommodations and are like, I can't put my 20x40 duct in your 6 inches of space. Like
we're going through.
Have to come back.
All right.
Okay, so something I learned about Carl with working with you, and I think it's so cool we have the opportunity to work together quite often, but is that I've always wondered, I lay out the roof for certain rooftop units. The weights are coordinated, the openings for the RTUs are coordinated, the return and supply air and through the building. So I have openings shown in my roof deck. I have the unit shown and I have supports for it. Then all of a sudden I get a call. It's like, hey, the unit doesn't match, or the unit doesn't line up with any of your framing. And I'm like, oh my gosh, what happened? I go back and I coordinated things before permit. Everything was good to go. But all of a sudden things change. Why is that? What in your line of work, how is what you specify different than what actually shows up in the field? And why is that?
This is a good topic to bring up because we've discussed this in the office as structural. The mechanical engineer and our relationship with the equipment and our equipment reps is very different than your equipment. When you specify a beam, you don't care who provides the beam because your beam is going to be a beam. No air handlers are made similar in the world for us. You know, that's like saying I'm going to have a truck and I need a 4-door truck. That is not like, there's so many 4-door trucks in the world. Like
it's performance specified.
It's performance specified. And so we design, and we have a basis of design that we've designed around, and we've selected that. But a lower bid product can come in and change that and be a different air handler. For the majority, it comes to then on the responsibility of the contractor to say, okay, you need to now coordinate with everyone that you want a different opening, you want a different location, it's a different weight, and make that happen. Your system shouldn't change to the point that you guys get screwed. Like if you guys get screwed, your mechanical engineer because it should be that the contractor now has to jump through hoops to make you fix what he wants to change. That's the goal that a good mechanical contractor should have. What happens is, I'm trying to cover every base. So say you want a car, and you want a very specific car. You want a Ford Raptor. You want a nice big truck. But you can't say, I want a Ford Raptor. You have to say performance requirements and hope that the only one that can meet that is the Ford Raptor that you want. But instead, you get like some Swedish car you've never even heard of that they're like bringing over. It's some guy who, usually it'll be like a Malaysian air handler manufacturer who's trying to get into the market and is selling this air handler super cheap. You've never even heard of this model.
All metric,
but it can fit the specs that I'm saying. And it's like, I didn't have a tight enough or the right specifications, or maybe I missed one, if I had talked about this specific thing, the opening width, if I had scheduled the opening width, they would have had to meet that. But
wow. You mentioned bid, like this is something totally outside of the structural realm. You got into it enough now, so I know what you're getting after, like that it's performance based, and then different companies, right? Do they all just bid? Like, what do they have that fits this need?
Right. And everyone's trying to meet that need, and everyone's trying to basically schmooze your mechanical engineer to be the basis of design. You guys experience it in air handlers, which we tend to be. So if you have a smaller air handler, the smaller your air handler is, honestly, the more likely it's going to change. The bigger the air handler you guys are dealing with, the less likely it's going to change because it's meeting a very specific need. If you're in one of the, we call them burger units, because they're just like plop and drop train or carrier units that sit on top of every like Burger King in the world. Those are super common replaceable units that I could, a dozen contractors will meet the specifications for, and I have no idea what I'm going to get when I go out there.
So I guess for anyone listening, Carl, you and I, we have the relationship to where if you get a different unit, you understand it's a different size, different shape and plan, and the holes are different, that you come and tell me, right? We talk about it. Hey, Zach, this is changing. Let's get this coordinated. Let's get this going. And now let's say we didn't work in the same office. We didn't have that relationship. It's pretty much left up to the general contractor to coordinate all that then.
Yes. There's a lot of that goes on because at that point we're into the submittal phase. We've kind of stepped back, and we're expecting that the contractor's now accepting that change. My best advice for a structural that really your mechanical should be asking for is that your rooftop openings should not be down to the inch under, like, where they're going to have a ductwork drops. And if it's like a 12 by 40, you shouldn't frame out a 12 by 40. Give us a big box under the unit and just leave it open. Like, give us a big frame out. And then if they go and set the unit and they're off by 2 inches, when they lift this 200,000 unit with a crane, and you're not like trying to set right on top of your opening. They're not, just make a big opening under where our drops are and let us just go from there.
I like that.
And it's so much helpful for us when you don't try and frame down to the gnats, the small opening.
I totally agree. It's so hard because to me, structural engineering is more or less black and white. You give me an opening, I frame that exact opening, right? Like it's really hard to be like, well, I'm going to frame that opening plus 2 inches, right? Because you talk to another mechanical engineer, right? You're one opinion. I talked to another mechanical engineer and they're like, I want 4 more inches, right? Or, 6 more inches. So it's very challenging to find where that is. But I think I'm going to drive this home this whole episode is.
What are you going to say, Zach? Is this going to be new?
Communicate. This isn't new at all. So.
Well, you're obviously a communicator. Look what we're doing.
So your mechanical unit can change weight, can change size. The openings can change. The units that you typically specify specifically, because we can't get other people's opinions at this point on what they do, but are you finding that those units, when they get changed out, are lighter or heavier?
It's a roll of the dice.
Okay. So cheaper units aren't necessarily lighter units.
Right. And a lot of times, so a cheaper unit is not as well designed, and so it'll be bigger so that it can fit more options in the unit. So it'll be bigger, which is heavier. And then they'll have one box size that they'll put different stuff in based on what they're trying to do, where a very efficiently designed unit will be smaller and tighter designed, and so will be lighter.
And I guess with these mechanical changes of the unit, could that potentially change the ductwork? Or since you performance spec what you need, the only change is the unit?
It can change the openings. Every air handler has their own techniques and designs for how there's a lot of stuff that goes on in that box, and how it's all laid out and connected together is no one has anything exactly alike. Everyone does it completely different. So having just kind of like a general space, for these openings is the perfect perfect option for you. I think there's not really like a good solution for when these change are really kind of, we don't want it to change. We want what we designed to go up. And so we don't like when it changes either. A lot of times, if you can give us an excuse of why we can't use the new unit, we'll tell the contractor that, and they'll have to go with the unit we selected. That's what we want to happen. That's why we selected that unit. So often I'm going to like people and I'm looking for excuses. Hey, electrical, does this new unit work? Does it not work? Tell me it doesn't work. Hey, structural, does this unit not work? Can you tell me it doesn't work? And then I'll go to them and say, your unit's double the weight. Nope.
Yeah.
And so the mechanical engineer wants their unit. So
Yeah, and I think that makes a lot of sense. So, Carl, something we've done on this show with when we have professionals on here, and you're a professional licensed engineer, is what is your 3 tips to a young engineer starting off their career? What is
structural or just a young engineer in general?
Engineer in general. We typically and have almost completely only interviewed structural engineers, so they have very, very specific tips to a structural engineer starting off their career. What, in your opinion, at a kind of higher level engineering in general, do you think is smart for a young engineer to think about? And maybe in this sense, I know I'm putting you out here on the spot, but maybe in this sense, what should a young structural engineer be thinking about when they're designing a building with respect to mechanical?
So just my philosophy, and I think why I try to be a good engineer, what I think helps me be the engineer I am, is ask lots of questions. Ask everyone's questions. You got some doubt, ask the mechanical engineer, well, why is this unit heavier? Well, why did the openings change? Ask them. And you can be polite about it. And as you said, communicate. But I'm a question asker. I ask everyone questions. I'm always drilling everyone with questions.
So maybe your tip to a young engineer would be don't be scared to ask questions.
Yeah. Ask lots of questions. Ask for explanations of why they want to do something the way that they're doing it. Don't just let them like, oh no, I have to go here. Be like, okay, well, what are the other options? Why is this the best option you're going through? And then same wise, explain your point of why this is the best option for you. Here are my other options. Here's why they're not as good. Have you thought through your other options and why they're better or worse? Have you thought of ways to accommodate the mechanical engineer and why what cost is it adding to your project? And maybe he is a thing that, that quadrupled his costs, but it only doubled your cost. Okay, well, let's discuss and talk about it. And instead of just like, oh no, that doubles my costs. I'm like, well, it saves me a lot more money on this end.
Yeah.
Which I've had rooms that I went in and like, I can make your giant beams work, but it's going to like quadruple my costs. And they came in like, oh, that's only like a couple $1,000s more per beam to make my beams a little thicker. It's cheaper for me to make them thicker. And then I've had other times where they're like, no, that's way more expensive for me to make thicker beams and raise them up. You should do your other option.
Yeah, I think that's great advice. Carl, I really appreciate you being on the show this week with us. I think.
Thanks for having me, guys. Thanks for bringing me in and asking all the questions. And
I think we're going to have a lot of questions from the show. This is our end of season, our first season of the Structural Engineering Podcast. We wanted to end it on a high note discussing mechanical systems. And so
your first other discipline you've had on?
Actually, episode 2 or 3, we had another mechanical engineer, but he did not do HVAC systems. He started off as a boat engineer, designing bolt hulls, however you say that word. It's very difficult to say that word. A hull. And then he now does medical equipment. But in the sense of the building, other engineers are working on a building. You are, and so I would assume this podcast will drive many emails and messages as we get them. Max, when we don't have Carl on the show, we get questions about mechanical systems and and
Max gonna start interacting with his mechanical.
I might reach out and just see if they want to talk.
So anyways, Carl, I don't think
Glad-
this will be the last time we have you on the show. I really appreciate you being on this week. It really does mean a lot to Max and I that you took the time out of your day or your evening, I guess, to sit down with us and help structural engineers, specifically young structural engineers, to grow their career and become better. Max, what did you take away from this? What's your closing thoughts?
Don't shade the shear walls. Maybe shade the not shear walls, and then you're good. And also communicate. Get in touch with your mechanical engineers ASAP before you even do anything. Just go hang out, see what their system's going to look like. Talk about beams.
I couldn't agree more with that statement. And I think that goes with every discipline, not only the mechanical, but your architect, your civil, electrical, we never deal with, but networking is always good. Anyways, thank you guys for joining us this week on our episode here with Carl and discussing with mechanical systems. This will be the end of our first season of the Structural Engineering Podcast. We will kick off the second season of the Structural Engineering Podcast after the first of the year. We're super excited of all the new things that are coming to this second season. There's some sponsorships and partnerships really that we're very excited about to jump off in the second season, as well as a new website, and we're really revamping things. We learned so much, Max and I, about producing a podcast, audio, websites, content, interactions, and we're super excited to jump into the second season with you guys, and we really appreciate so much your guys' questions and comments and listening to the episode. So again, reach out to us, email, Instagram, Facebook, any way you want, and we'll catch you guys next time.